Welcome student to today's session of the subject, that is unit 1 of design of machine element 1. In the previous sessions we have covered the joints, that is knuckle joints and quarter joint. So moving ahead with these topics, now we will cover levers. Lever is defined as mechanical device in the form of rigid bar pivoted about the fulcrum to multiply or transfer the force. The ratio of load to effort, that is F by P, is called the mechanical advantage of the lever. Basically, the lever is a rigid bar hinged at a point called the fulcrum and used to lift the load by the application of a small effort. The ratio of effort arm to the load arm, that is L1 by L2, is called leverage. Taking moment of forces about the fulcrum, we will get F into L2 equal to P into L1. So where F is the load and P is the effort and L1 is the effort arm and L2 is the load arm. So taking P to the left side, we will get F by P, that is load to effort ratio, equal to effort arm to the load arm ratio. So that is mechanical advantage is equal to leverage. We will see the types of lever. There are three types of the levers according to where the load and the effort are located with respect to the fulcrum. The effort arm and the load arm. In the lever, the perpendicular distance of the effort from the fulcrum is called the effort arm, and the distance between the load and the fulcrum is the load arm, as we can show in the right side of the figure. So we will see the first type of the lever, that is class 1 lever. In this type, the fulcrum is located between the load and the effort. In this case, the effort arm can be kept less than the load arm or equal to the load arm or more than the load arm. When the effort arm L1 is less than the load arm L2, the mechanical advantage is less than 1. When the effort arm L1 is equal to the load arm L2, the mechanical advantage is equal to 1. And finally, when the effort arm L1 is greater than load arm L2, we will get the mechanical advantage greater than 1. The application of class 1 type of lever is rocker arm for the overhead valves of internal combustion engine, bell crank levers in railway signal mechanisms, and the class 1 lever is also used, that is the levers of the hand pumps, as shown in the figure. Moving ahead to the second type of the lever, that is class 2 lever. Here in class 2, the load is located between the fulcrum and the effort. In class 2 type of lever, the effort arm L1 is always more than the load arm L2, and the mechanical advantage therefore is more than 1. The application of second type of lever is lever loaded safety valves mounted on the boilers. The second type of lever is shown in the figure. Next is third type of the lever or class 3 type of lever. In the class 3 type of lever, the effort is located between the load and fulcrum. In this case, the load arm L2 is always greater than the effort arm L1. Therefore, the mechanical advantages in third type of lever is always less than 1. The type 3 lever is shown in the figure and explained in the right side of the figure. The third type of lever is basically used for picking fork. In the next session, we will see the design of the angular lever and its procedure. Thank you.